Welcome, everybody. Today we're going to look at the quintessential tank and pipelining Enviroline 376 and the series. Why is it quintessential? Because we maximize value, we minimize risk, and we get very good life cycle costs. My name is Mike O'Donoghue. I work in Canada. I have a PhD in chemistry from the University of Surrey in England. And I've got 35 years in the protective coatings and marine industries and published over 70 papers. Many of the topics that we're going to hear today are covered in those papers.
My name is Vijay Dada. I have a master's in chemical engineering, and I have over 50 years of experience in marine and protective coating. I have also co-authored 70 papers dealing with various topics for protective and marine coatings, including some of the tank linings.
And we're going to talk about many things today in terms of thinking, to think or not to think. If we look at the brilliant genius Albert Einstein, what did he say? We cannot solve our problems with the same thinking we used when we created them.
Talk about thinking, Mike. Let's talk about why and where we line tanks and pipe. I'm going to talk about why we line the tanks at the first place. Number one is corrosion protection. Normally the coatings acts as a barrier between the steel and the cargo. So it will protect the steel from corroding. Second is protection of product purity. Finished product line whole of acid to prevent contamination, say with the rust particles. And the last one is the material integrity, because some of the chemicals like ethanol can cause stress corrosion, cracking of valves. So we have to line the whole tank. Now, where we use these tanks linings, refineries, chemical plants, water and wastewater, as well as oil and production facilities. Now, talking about chemical tank linings, let's go back to the history in the development of the chemical resistance tank linings. Way back in the 50s, we did not have any need for very aggressive chemicals. So we would use simple epoxy coatings cured with the polyamides, and that will give you the satisfactory performance. As the need for aggressive chemical arose, so did the development of the tank linings. So we moved into phenolic epoxies, Novolac epoxies, Novolac vinyl esters, and the latest development is polycyclamine cured Novolac epoxy. This is a huge innovation, both solvent-borne and solvent-free. And that's what Enviroline 376 is. And we're going to be talking about Novolac epoxy coating cured with polycyclamine.
If we look back in history, we'll also see that with crude oil storage temperatures, there's been epoxies, phenolic epoxies, and Novolac epoxies used as the temperature goes up. In the old days, where we had simple bis-A epoxies that would handle the light crude oils, and then heavy crude, you would need, say, for example, Novolac epoxies, whether thin film or thick film. But as the temperature rose above 100 centigrade, then we need even more thick film and thin film Novolac epoxies.
Now, talking about the development in the tank linings, let's see what are their advantages. Now, there are technology improvements made into the lining technology. Number one is the higher volume solids. So what do? They really give you lower solvent emissions. Fast return to service, that will give you the more productivity. And then, of course, we have a wide range of chemicals and temperature we can handle. And improved chemical resistance will give you longer life of the tank linings.
When it comes to epoxy linings, there's a very simple scheme of things. If we look at the 4 stages, the A, B, C, and D stages of epoxy linings, we start with the monomers and we react them together. And the polymers are formed with the linear growth. Then they branch out and ultimately set into a D stage, the final stage, where you have a vitrified gel and you have your polymer fully filmed epoxy lining, which is a coating system that is used widespreadly in the oil patch.
Now, look at the different epoxy resin, Mike, what we use here. There are several different epoxies. Bisphenol A, bisphenol F type epoxy resins, epoxy phenol Novolac, and epoxy cresol Novolac. These epoxy resins have a different functionality, and then they can be cured with a lot of different curing agents. Mike, could you tell me what are the different curing agents we use with different type of epoxies here?
Yes, as you can see, there's a variety of them, and each of them provide a hydrogen atom to react with the oxygen on the epoxide group. And primarily in the oil patch nowadays, we're using the Novolac epoxies, and we're cross-linking those with the polycyclamines that you can tell us about with the Enviroline 376. But there's a variety of curing agents, as you see, and they're all providing hydrogen atoms to react and co-react with the epoxy.
Now, look at this diagram here. This is epoxy resin. This epoxy resin, Mike, you mentioned about the oxygen and the hydrogen. That's what we do. We really try to open up this triangle there. And this triangle, when it opens up, it gives you the polymer chain as well as produces hydroxyls, which gives you very good adhesion to the steel. Now, talking about the polycyclamine curing agent and the Novolac epoxy resin, as a formulator, when we formulate these coatings, we want to make sure there's a minimum free volume. Now, why we want the free volume to be so little? Because it will not have penetration from the water and other cargoes. But what happens is when we raise the temperature, this free volume can increase if the coating is not formulated properly. So what our goal here is to keep the free volume low even at higher temperature. And this is achieved by using proprietary fillers, additives, and also controlling the stoichiometric ratio between epoxy and the curing agent. Now, let's talk about some of the features of Enviroline 376. As we mentioned before, it's a polycyclamine cured Novolac epoxy lining, and it's reinforced with fibers and flake key pigments. It's solvent-free, and you can use it up to 80 mils in one coat. It can handle a wide range of hydrocarbon resin, even at higher temperature, up to 194 degrees Fahrenheit. It's approved with the use of jet fuels, and there is a special classification here, EI 1541, and we'll talk about that in the later slides here. Conform to the API 652 for extended inspection, and it has a recoatability testing up to 28 days. So you can recoat it even after 28 days in certain chemicals.
You're kidding me, Vijay. The recoatability of nearly all the 100 solids epoxies with the very hard shore D ratings, you won't get the 28 days of recoatability.
Mike, I will show you in the later slides how we really developed that, and we'll discuss that in the coming few slides.
Look forward to it. We also look at 376 with the chemical resistance being very high, because the cross-link density that you pointed out earlier, Vijay, is very high. You've got short cross-links. So 376 will handle a variety of different chemicals, sweet and sour crude, especially important, say, for example, the oil patch where I hail from, aliphatic hydrocarbons, aromatic hydrocarbons, diesel fuel, biodiesel in the blends, jet fuels, a very large array of chemical resistance from Enviroline 376.
Now, Enviroline 376 has several advantages. Number one is very quick return to service, which gives us a lot of productivity. Usually a one-coat high build system, minimum OSHA issues, no risk of solvent entrapment, and no intercoat adhesion. That can save a great deal of time and labor.
Let me point out why you are mentioning these things, BJ. There's a fingerprint factor, which is particularly interesting because at our company, EXO, we are manufacturing products all around the world where if you fingerprint the constituents of the coatings and the material themselves, they're all identical. So what you buy in North America would essentially be what you buy in 376 or any of the coatings in Asia, for example.
That's fantastic, Mike.
376 curing, Vijay, you were mentioning about the speed. If we look at this particular aspect, regular I'm trying to think what I'm trying to say here. Regular epoxy thin film, for example, would take 7 days at 77 Fahrenheit to cure. But if you look at the technology we're describing, and today with Enviroline 376, the curing is so fast that you can walk on the coating very, very quickly in a tank or handle a pipe very fast, 8 to 10 hours of curing. So even when you have a shore D of around 80, it's that fast to cure. Then, if we also think in terms of a tank where we've got a flexing bottom of the tank, if we ever get a situation where that tank, even though it's flexing, has got a perforation in its bottom, in the tank floor, for example, if you have 376 in that tank, then you can actually get hole bridging for a certain amount of time, obviously, with the coating being on the tank floor. And what we do there is essentially say to ourselves, right, we're going to test that and prove it. If the hole size on the tank floor on the perforation is about 2 inches, and we apply pressure of about 2 bar on the coating that is over that 2 inches, as you see in some of these slides, you'll notice that the coating has withheld and sustained that pressure, so it hasn't broken. So this is a very interesting aspect of the 376 performance.
Now, Mike, you were asking before about the overcoating, and let's talk about the overcoating of a 376 here. So what we do in the lab is we don't check only the dry adhesion of the coating in terms of decodability. We will spray the panels at different temperatures, cure it, and then we apply the second coat at different intervals, starting from 16 hours or 2 hours and going all the way to 28 days, depending on the temperature here. After that, we will immerse these coatings or panels into the various cargoes. We will have divided the cargoes into 2 categories. Number 1 would be, we would call it the black oils. This would be like a crude oil and other heavy oils. And the second one would be a clean cargoes like ethanol or ethanol blends. Because the purpose of the wet adhesion is because the cargo can penetrate through the top coat and cause intercoat delamination. So we have to make sure that we check the wet adhesion, and that's where it gives us the 28 days in the black oils. It could be shorter in the clear cargoes like ethanol and others. And if the intercoat adhesion is not over 1,000 psi between the 2 coats, we consider it's a failure, and then we have to go further investigation into the coating.
I appreciate the clarification. It was rather remarkable, and it's quite significant that it accomplishes this 28-day overcoating. Now
we also ran
a
wide range of tests on Enviroline 376, and one of the key tests here is a 12-month immersion test into various cargoes. So when the coating is put into the marketplace for a purpose, so we make sure what is going to be carried into those tanks, and we do test those cargoes, as you can see here, crude oil with water, ethanol, various amines, sodium hydroxides, ethanol and ethanol blends for up to 12 months.
All the more significant. Sorry to have interrupted you there, BJ, but that's terribly significant. And in terms of what we're going to look at, say, in the oil patch, there's pre-qualification requirements of coatings to perform, and they're often done with accelerated laboratory experiments to see just how well they're going to perform and whether they're going to be on the specifications. In that regard, Atlas cell and CD testing is often utilized, and you see these configurations here. The Atlas cells are either pressurized or the standard Atlas cells, and then the CD testing is carried out to conform and make sure the coatings conform to certain standards. If we look at the cathodic protection, for example, CSA Z245, we've tested the Enviroline 376 at 80 centigrade, 176 Fahrenheit, and it's showing exceptionally good small amounts of radial disbondment, far lower than the standard requires, of about 20 millimeters, but anywhere around about 5 to 8 to 9 millimeters.
Mike, you were talking about the autoclave and test. Here are some top pictures here showing the various autoclaves. What we do is we run these, it's like a pressure cooker. So we'll prepare the panels and put it into this autoclave test and expose them at various pressures and temperatures and the environment. So testing is really, really important. Lab testing also is really important to have a field testing.
Yes, I think that's worth highlighting. If you take the same panels, the identical ones that you put into, say, for example, the lab accelerated test, and put them into, say, pipes or tanks, down P patches, etc., as you can see in some of the pictures, and then in situ test concurrently with what you're doing in the laboratory, then you can compare and contrast what you get. because what we have in the laboratory is essentially indicators of performance, whereas if you do it concurrently, you'll actually get real life performance that you can compare and contrast.
That's great, Mikey, because that gives you a lot of confidence into the product, how it's going to perform. Now, I mentioned about the EIS, which is electrochemical impedance spectroscopy. What that determines is the barrier properties of the lining. Now, what we do is we determine the impedance as a function of frequency. And when the readings are high, like a 10 or 11, that means the coating is going to give us a very good barrier protection. As the EIS value decreases, then you don't get a good barrier protection. As you can see here in the graph here, that the protection begins at 6, but that's not very good. So we try to shoot around 9, 10, and 11. Here is a typical example of an autoclave results. It's a run per NACE TMO 185. In this case, we have a 3% sodium chloride solution at 300 degrees Fahrenheit and a little over 70 psi. Once the panels are exposed and evaluated, there were no blistering, cracking, or rusting on any of those 376F panels, and it gives excellent adhesion to the steel.
I mentioned a few moments ago the CD testing, didn't I, Vijay? And not only the CD testing is examined, but we look for the flexibility of the coating at temperatures down to -30, the impact resistance down to -30, with Enviroline 376 conforming to Z24520 rather. We'll find there's no cracking and no defects. And the CD results, we've just mentioned those a few moments ago. Now, in order to get really good results from what we do, it's great to have the good coating like 376, but we've also got to make sure that the contractor applies it beautifully, properly. The surface preparation, obviously, is key here. And talking of keys, we want an angular profile, as you've seen in this particular slide. And we've written papers about this, actually, in the old days. It was called Angels and Demons, and we talk about the impact of the actual profile on the coating performance.
Now, if you see it in this, here is a steel profiles. The left-hand side is a grit blasted steel with a 3 mil profile. As you can see, it gives us a very jagged profile, Mike, which you mentioned, and it's a kind of really required for the solvent-free epoxy coating. The middle picture here is the pitted steel, including some of the omega bits, and the purpose is to really clean these bits before we can apply the coatings. And the right-hand side is a typical weld. As you can see, there is also pitting around the weld areas, and that also has to be prepared properly when we apply these coatings.
I like the application of 376 because in order to get the material to flow beautifully, it's best to use it using a hydrocat as opposed to hot potting it, and you'll get a really lovely film that will fill in beautifully. That slide that you showed a moment ago where we see the angular profile requiring the coating to have good flow. We want good molecular mobility of that particular coating, and we get that by using a hydrocat to give the heat that is required.
Let's talk about some of the case histories for Enviroline 376. Now, even though we have painted thousands and thousands of tanks at various locations throughout the world using 376, this is one particular one in North American refinery, which was painted in 1997. It's a huge tank, 140 feet diameter tank. The previous coating really failed badly, so that the customer chose 376 to be applied into this tank because they really wanted a quick return to service. And they were so pleased with the application, the cure, as well as the performance of the coating that they gave us several additional tanks with the 376 at this refinery.
And this particular example of a case history, as you say, there are so many thousands of them. We've got a refinery which goes back to 2001. So coming back to an earlier comment that we made was that you'll get 20 to 30 years if you apply this properly with a good specification and so on. And you've got a situation where you can handle crude oil, molten sulfur, crude feedstocks, water, different types of materials like that. You mentioned earlier caustic, even spent caustic, for example. So there's a variety of different tanks that have been coated, and here you see some examples of that. So it's very, very friendly for the refineries, Vijay.
Looking at really the whole performance at a glance for Enviroline 376, it has a much lower applied cost because it's a single coat, excellent chemical resistance, and very quick return to service when you're in a bind.
The impact resistance is really good, as we've got all the data for it. Temperature resistance, 180 Fahrenheit. The CD despondent testing, excellent. And all these physical factors, physical tests show a really good performance of this material, and hence we can get the 20 to 30-year lifetime from its good, effective use. In closing almost, we'll now have a quick talk about some of the tank lining publications that we've got. We mentioned there's over 70 that we've done, but these particular ones are rather interesting because the first one is rather old, but it talks about the technical features, the actual technology and the curing mechanism of 376. The second one is somewhat different, but looking at the Atlas cell testing. Third is all about the studies of tanks, and it's rather an interesting one, isn't it, Vijay? I think it's one of your favorites, actually, and I'll ask you that if it is. And then we've got some others in there as well, some more recent ones. So you can read these, you can enjoy the practical aspects of it, and you can also, sorry, I moved my screen there. You can also look at the technical features of it.
Mike, is there any paper which was particularly written around for Enviroline 376 here?
Particularly that one in number three, the JPCL November 2010. This was done by an applicator and a big oil major, and very interesting. A great case history.
Very good. Thank you, gentlemen, for paying attention.
Thank you indeed.